All right, guys. Last one for fun sheet 1, number 4. 17 centimeter tall object. Object distance is 30 centimeters in front of the lens. Focal length is going to be negative 40 centimeters. So drawing that out, I'm just going to take you through step by step instead of having it prepped. So we're going to draw the center line for the lens. Here's the lens. I'm not going to do different colors this time. This is going to be the lens. The left side is a negative distance. The right side is positive. We're always drawing from left to right when it comes to our object and the light going through the lens. So our object is somewhere over here. Big object. And then, so we know the object is 17 centimeters. I'm going to throw that on there so that we know that the distance the object is from the lens is 30 centimeters. So U equals 30. And then the focal length is a minus 40 centimeters. The minus says that the focal length is here on the left side. It's 40, so it's greater than 30, so it's further left. So this is going to be the F. And it's going to equal negative 40. Why? Because it's over here on the left side. If you want to, I don't like to put it there. I'll just put it at 40 centimeters. Just remember in your calculations that because it's on the left, it is the negative. Alright, so again, what we're normally going to find, we're going to look for V, we're going to look for magnification, and we're going to look for the image size. Here we go. I'm going to put that over there just because I can. I don't like how it doesn't look balanced. So for those of you who are like me, there's a focal length over there on that side so that we have a balanced picture. Gotta love OCD. So minus 1 or negative 1 over U, which in this case U is negative 30. There we are, U. Plus 1 over image distance. And then we are looking for equals 1 over the focal length, which we were told that the focal length was a minus 40 focal length, minus 40. This becomes positive because there's 2 negatives. So we subtract 1/30 from both sides, and we're left with 1 over the image distance equals negative 1/40 minus 1/30. So, because I don't feel like fighting with, I know that it's 120. I don't feel like doing that. So we're going to go down here to this guy here. So we're going to do negative 1/40. Yeah. Minus 1/30 equals minus 0.0583. So 1 over V equals negative 0.0583. So again, here we are. We throw this over a 1, we can cross multiply. So minus 0.0583V equals 1. We divide both sides by this, so V equals 1 over minus 0.0583. And so I do 1 divided by the answer. No! 1 divided by the answer should get me about minus 17. I'm pretty sure that that's, he rounds. So image distance is about, this is what those mean. That means about minus 17 centimeters. So I think that that's an interesting correlation, but we're gonna ignore that. So minus 17 centimeters. If the object distance is 30, this is a negative, means that it's on the left side, and that somewhere between where the object is and the lens, this image is located. So we're going to say that this is 17 centimeters. 17 centimeters. So this is what our picture looks like right now. Boop. This is where we are. Now we're going to find magnification, since we know what the image distance is and the object distance is. So M equals V over U, which is equal to the image size over the object size. So if V is negative 17 and U is minus 30, equals to I over, and we know that the object is 17 centimeters as well. We know that our answer is going to be in the positive. And what does that mean? That means that the image is going to be erect. So we go minus negative 17, not minus, negative, that means that's something different. Negative 17 divided by, this is what I get for trying, I gotta tell myself to stop looking through the phone. Divided by negative 30 equals 0.5667. I always do to the 4. So M is about 0.5667, which is equal to the image size over the object size, which is 17 centimeters. If we throw a 1 underneath this, we can cross multiply. So we'll start with 0.5667 times 17, which is equal to I. You can see that. Because 1 times I is 1 I. So here it is. And then our number. So I'm going to take my answer. Actually, you know what? No, I'm not, because it's going to give me something slightly different than what we want. 0.5667 times 17. 9.63. So I is going to be about 9.63 centimeters. He might round it to 10. I'm not going to actually get up and go and check. So magnification from what we got is about 5. That was not, it's a 5.6. Can't, it's because I'm talking. 5.667. And that image is about 9.63 centimeters. So that you can see. This is the reason I don't break them up, is because we're using the same formula, and you can just take the next step or 2 down and get your answer. So we went and we were looking for magnification first. We took what we knew, which we had already found the image distance at 17. It was on the left, so it's a minus 17. We already knew the object distance, which is also on the left, so it's a negative 30. And then we also know what the object size is. It's 17 centimeters. It's positive, so it's upright. And we're going to later look for the image size. And since all of these are related, we can just go step by step down. We next found the magnification because of M equaling V divided by U. We knew what that is. So V divided 17, negative 17 divided by negative 30 gave us a 0.5667 rounded. So magnification is about a little bit over half. And then we took the next step to find the image size, which is 0.5667 is equal to I divided by 17, which is an upright image. And it gave us around about 9.63 centimeters, which tells us that this image is also upright or erect. So when we go to draw this, I do want the red. Now I want the red. I've been doing it with red. Let me do it with red. So the image distance is about 17 centimeters to the left of the lens. So that's going to be here. And that the image is going to be upright. It's going to be about 9.63 centimeters tall. What that tells us is we are, in fact, we are looking at a minus lens. We are working with a minus lens, and that's based on this. It's because our focal length is a minus 40. So when you bring the light through, the light goes across, beep, beep, and then it diverts. I need to probably start drawing these a little bit better to do. So when I go and it goes deet, 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 deet. Why did I do that wrong? I did that wrong. No, I did. Yes, I did. I did do it wrong. Okay. No, I was right. I was doing it right in the first place. Okay, so this dot here is for my image. This is for my focal length. So this line here should go beep, 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 all the way through to the focal length, which means that my object's a little too tall. And this line, this next one that goes through the optical center, is where they'll meet. I know I made that a little bit confusing just by doing that. I forgot that the focal length is all the way over here. That's what you get for drawing the same image over and over and over again. Make sure that if you're using the images, and they are a good guide, that you're doing them mostly correctly. And this is something you might notice on exams, bigger exams, like state exams and stuff, is that they will often put in the beginning of the directions that images are not drawn to proportion. Just be aware of why it's not. So number 4, we've got our image distance, our magnification, our image size. We have a minus lens. Our image is upright, so it is an upright or an erect image, but it is virtual because it is on the left side of the lens and does not travel through. If you have any questions, put them in the comments below. Thank you.